Hello, and welcome to my video on the January 2019 Algebra 2 Regions question number 34. In this problem, we are given that a of x equals this fourth degree polynomial and b of x equals x plus 2. We have to determine a of x over b of x in the form q of x plus r over x over b of x. And then after that, we have to determine is b of x a factor of a of x, and we have to explain this. So for the first part, to determine a of x over b of x, that's a fraction of two polynomial expressions, which is equivalent to the operation of division, which this year we handle that by doing the reverse tabular method of division. So we'll start by constructing our table. And the number of rows here we have in our table would just be 2, because the divisor b of x is just a x and positive 2. And then the number of lines that we need to draw here, again, because a of x is a fourth degree polynomial and b of x is a first degree polynomial, the difference in those degrees is 3, so we'll need to draw for ourselves 3 lines here, which would give us 4 columns in our table. And as always is the case, when we do a reverse tabular division, we want to start on the upper left-hand portion of our table here, and then we can fill out the outer parts. We would have 2x cubed, but you have to be careful. After 2x cubed, we have here 4x, and to go from x cubed to 4x, we're skipping over x squared in our dividend there. So remember, we have to put a placeholder here of 0x squared, and then we can continue with 4x and negative 10. So now we've completed the outer portion of our table, and we can start working backwards to get our answer. So above x to the fourth here, we should have x cubed, because x cubed times x is x to the fourth, and we can complete our column. This here should be 2x cubed, and then when we complete our diagonal, remember, these have to add up to what we see on the outside. Because we already have 2x cubed here, we don't have to add anything, or we have to add 0 to 2x cubed to get this. But I'm going to put a placeholder here of 0x cubed, not just 0, to help with filling everything out. Because then above our table here, we can write 0x squared, complete the column. 0x squared times 2 would give us still just 0, or 0x squared. And then when we complete the next diagonal, again, because 0x squared is on the outside, we would just add 0 to 0x squared to get this. But as a placeholder, I'm going to leave 0x squared there, and then continue working backwards. Above here, we would have just 0x. When we multiply out here, 0x times 2 is 0, but again, I'm going to leave the x there as a placeholder, so we have 0x. And now when we complete this diagonal, we'd have to have 4x there to add up to 4x. And then working backwards above, we'd have 4. 4 times 2 is 8. And then now we've completed our table, and we can write out our answer in this form. The q of x is what we have above our table, which is simply just x cubed plus 4. If you wrote plus 0x squared plus 0x in there, that's fine, but it just simplifies down to x cubed plus 4. And then for the rest of our answer, the r of x represents the remainder in our problem. And remember, the remainder, since these numbers are not the same, there is a remainder. And to determine what that value is, just think about, what do I have to add to 8 to get to negative 10? And to do that, that would require us to add negative 18, and we would put that negative 18 over the original divisor of x plus 2. And that's the solution when we perform our reverse tabular division. Now, the second part of the problem is b of x a factor of a of x. Well, remember that when we get a remainder that's not 0, then that means that the b of x doesn't divide a of x evenly, and thus it can't be a factor. So no, b of x is not a factor since we get a remainder of -18 when we divide a of x by b of x. And that should be sufficient enough for an explanation to why b of x is not a factor of a of x. So I hope that this video helped you out with this particular problem. As always, good luck with all your studies, and thank you for watching. Take care.